Hi everyone. In the problem statement of get matrix zeros, we are going to given an m cross n integer matrices, and if an element is 0, then set the entire row and column to 0. This problem statement is very self-explanatory. So in case, right, any column or row value is 0, then we are going to set the entire row and column to 0. Now for that first we are going to create two trackers to understand which row and column have a 0 value. So for example, let me create a call dictex, an empty dictionary, and row dictex, which is also going to be an empty dictionary. Once I have done that, I'm going to loop through the entire matrix. So for I in range 0 to length of our matrix, for j in range 0 to length of our matrix, and I'm taking the width, so it would be 0. And if matrix of I and j is equal to 0, in that case, if I not in column dictex, in that case dictex of I is going to be initialized as 1, and if j not in row dictex, then row of dictex of j would be assigned to 1. Now again we are going to loop in. So here we have keeping a track of all the rows and columns where the 0th index has been found. Now in the second case, right, now we are going to transform all the values of those rows and columns to 0. So the first was the tracker, and second, let me create a transformation, or where we are going to replace all the values to 0. So for I in range matrix, and for j in range of 0 to length of matrix of 0, the first index to get the width, and if I in column of dictex or j in row of dictex, then matrix of I and j is going to be set a value of 0. And if you can look into it, here we are doing an in place replacement. So let me run the code. I hope there is no spelling errors and it run properly. Now let me submit the code. As you could see, we are getting a runtime of 100%. So it's very efficient. And here, right, even though you are looping through the loop, so it would be big O of n square, you can see 2n square because you're looping through that matrix twice, but that is required for us to get the values, so there is not much we can do from that side, but otherwise it's pretty efficient and our code is running properly. And we have done an in-place replacement, so our memory is also going to be lower. And that's all for this video. See you in the next one.